Assalamu alaikum, sir. My name is Ezzatun Nesa. My ID is last two digit 25.
Assalamu alaikum, sir. My name is Sumia Laboni. My ID last two digit is 02.
Assalamu alaikum, sir. My name is Aftabur Tonmoy. My ID is last two digit is 05.
Today's our presentation topic is noise cancellation using adaptive filtering. Now I describe my presentation part. Describe about my first slide in project. In this figure, in this picture, we can see that here we using MATLAB and then adaptive filtering with LSM algorithm. And at last of our project, we show our live demonstration. Now I describe about my second slide. In this slide, we can see here the table contents of our project. Problem statement, LSM algorithm, theory, system block, so on, and lastly we can show our conclusion. Now I tell about, first of all, noise. What is noise? Noise is an unwanted signal that mixes with our real signal. Noise is very problem for our signal because it distributes the real signal, reduce our quality. And secondly, we can describe about adaptive filtering. What is adaptive filtering? Adaptive filtering is a smart way of filtering a signal where the filter automatically changes itself to give better results over time. Now I tell about what is adaptive noise cancellation. Why we can use this? Adaptive noise cancellation is a technique that automatically removes unwanted noise from a signal by using special filter that learns and adjusts itself while listening. What is the purpose, key features, and applications? Now I tell about one by one. Purpose: remove unwanted noise from desired signal in real time. Then key features: adaptive automatically to changing noise characteristic. Applications: hearing aids, headphones, communication system, and biomedical signals. Why LSM algorithm? Simplicity, robustness, real time, and adaptive. What is simplicity? Easy to implement and understand. Robustness, work well in various environment. And thirdly, real time, low computation complexity. And lastly, adaptive, continuous learn and adjust. Problem statement. In scenario, noisy signal enhancement. What is the challenge? Noise characteristics change over time. It's change many times in a one signal. Unknown noise source properties, real-time processing requirements, and multiple noise sources. Now I tell about what is the basic difference, traditional and adaptive approach. Which one is best? Now I tell about adaptive approach is best. Why adaptive approach is best? Because here we're using multiple coefficient. In traditional approach, we use fixed coefficient. That's why it is a limitation effectiveness. Now I tell about LSM algorithm theory. In this slide, we can see the core principle of LSM algorithm. The full form of LSM algorithm is least mean square. First of all, objective, method, and learning. What is the objective of LSM algorithm? Minimize the mean square error between this desired and actual output. Then I secondly described a method, gradient descent optimization, and learning iterative way we can change and adjust our way. What is the key equation? Now I tell about the key equation of LSM algorithm. Wn plus 1, Wn mu into En and Xn. And Wn is filter weights, mu is the step size, and En is the error signal. Then learning process is prediction, compare, and adaptive and report. Now I would like to my next presenter, Sumia Laboni. Please explain. Next slide.
Ezzatun Nesa. Here we can see the overall system architecture. Here is the noise source, that is N of T, the unwanted sound or disturbance coming from the environment. Then primary microphone capture both the speed and the noise. Then output this is S plus N1. This is the noise signal what we want to clear. Then reference microphone, place where it capture mostly noise only, N of 2, not the actual speed. This act as a reference to understand what the noise sound like. Then adaptive filtering, WZ takes the noise from the reference microphone and tries to match it to the noise in the primary mic. LMS, least mean square, is the learning algorithm that update the filter. Then delay aligns the timing of speed and noise signal for better subtraction. Then subtraction unit, then D of En is equal to D of N minus Yn. Then final output E of N is the clean signal, ideally containing just the speed. Then mathematical foundation. So signal model, there are the primary signal S of N and N of 1N. That is, S of N is the desired signal and N of N is the noise component. Then reference signal N of 2, that reference noise correlated with the N of N1N. And then filter output, here we can see the equation that error signal E of n is equal to D of n minus yn. Here first we can see the primary signal D of n is equal to S of n plus n1n. Then we put there, then we get the output S of n plus n of 1 n minus y of n. Then we have to update the weighted, that is the equation, then the cost function, then the coverage condition. Then implementation details. In step 1, here we use f of s equal to 8000 and duration 5. In here clean the here remove all the variable from the memory, and duration we take 5. Then we calculate the t is equal to 1 divided by f of s, then the frequency divided the time vector. Then step 2, generate the clean signal. Clean signal is multiply the signal into 2 pi 300 into t plus 30% of sine 2 pi 600 t. Then step 3, generator base noise source. The base noise random size, we take random size base noise. Then step 4, create the noise and correlation for the noise signal. At the noise signal, with microphone there are 2 signal. Then noise signal is equal to 0.5 into base noise. Then the create noisy speed signal with noise equal to clean signal plus add noise for the signal. And then store the original signal from comparison, original signal with noise and the original clean signal. Then step 6, we use the LMS adaptive filter that reduce the step size from the battery stability, filter length, filter width and input buffer. Then the signal plus LMS algorithm for n equal to n length, signal with noise, buffer equal to noise signal, and the calculate the filter output y of n is equal to w into buffer. Then the calculation error E of n is equal to signal with noise minus y of n. Then update the filter w equal to w plus mu into E of n into buffer. Display the progress every 8000 sample in 1 second. Then I will call my next presenter to continue the presentation.
My name is Tonmoy. Now I start my part. Here we see the signal to ratio calculation. Then we take 3 type of SNR. First of all, the before of comparison, and we convert it into a decibel by 10 into log 10, and then after SNR same, and the improvement by compare before and after SNR. Then we save our files in this way. This is the plotting part, and the result and the performance. A signal to noise ratio SNR is here is the calculation, and the typical result SNR before, and if it is -5 to +5, and after filter it can be 10 to 20 dB, and SNR improvement is 10 to 15 dB. Now convergence analysis, learning curve, conversion time, and a steady state error. Here is the visual result, time domain plots, frequency domain, learning curve, performance metrics, and the audio. This is the visualization of our project output. Here is the main clean signal we created. Then we create a noise. Then we combine them into a noisy signal. Then we use electric filter and get a result. This here we can see the green part is clean signal, red part is signal with noise, and the filtered output is green part. Blue part is blue part is the clean signal. And here is the weight value. Top weight value at approximates 6 step, and it is 0.8. This is the applications. There we use our system, and this is the advantage and limitation of our projects. The advantage is simple implementation, low competition cost, reverse performance, automatic adoption, stable convergence. And the limitation is convergence speed, step size selection, correlated signals, performance scaling. Then the comparison. This is the comparison with other LMS algorithm. And next we are share you with a live demonstration. Hello sir, this is our project. We make our project in MATLAB as your reference, and here is the code, and our files save in this folder. Now we run our project, run it. From our presentation slide, we my previous partners say that this is the output of our project, and we divide a 5 second for the frequency, and here is the SNR before filtering. It's 1.34, After filtering, it's 13.77. So the improvement is 12.4. As you can say, it's between -5 to 5 dB. It's between 10 to 20 dB, and the improvement between 10 to 15 dB. Then this is our all file. First of all, we are trying to show you the clean signal. And this is the noise wave we created. And this is the noise signal. After using the filter, we get our output, and the output is final filter output. So this is our presentation. Thank you so much, sir. Assalamu alaikum.